Welcome back, everybody. I'm Travis with Linux Academy. In the previous lesson, we started working with some of the Docker networking commands, and in this lesson, we're going to continue to build on top of that. We're going to start off by going and creating a new network, but this time we're going to go and specify a subnet as well as a gateway. We'll be executing a Docker network create, but this time we're using two flags. We're using the subnet flag, and we're going to go and specify the CIDR block of 10.1.0.0/24 and the gateway of 10.1.0.1. We're going to be calling this network BR02. Now, when it comes to specifying subnets, we need to make sure that we're using private IP ranges and not public IP ranges. This means that we'll be using 10.192. and 172. Okay, so let's go and create this new network. Now that BR02 has been created, let's go and list all of our networks. Now I want you to go and take a look at the network ID here. When I go and execute ifconfig, our network is going to be named after that ID. The interface is being prefixed with BR, which stands for bridge. And then we have the ID of BR01. And we also have BR02, BR being for bridge, and then the ID of the network. Now that we're done looking at the interface information for BR02, let's execute a Docker network inspect. The main thing I want to point out here is that we have the subnet information that we supplied when we created this network. We're not having the next available subnet being assigned to this network. This is the one that we specified when we created it. And the same thing for the gateway. Now we're going to do something a little risky. We're going to be running a Docker network prune just to go and get rid of all the unused networks. But first, I'm going to destroy the container I created in the last lesson. So I'm going to list all my running containers. Now I'm going to go and delete the container by executing docker container rm. I specify the ID of the nginx container. And because this container is running, I'm using the -f flag to force it to be deleted. Okay, just to quickly verify, I want to make sure that all my containers are destroyed, which they are. And now we can proceed with the prune. It's also worth noting I could use the -f flag to bypass any kind of verification. Okay, so two of our networks were deleted, BR01 and BR02. Fortunately, Docker is smart enough to know that it's not going to go and delete any of the default networks. So when I execute docker network ls, you can see we only have the defaults remaining. Another thing we can do is we can actually go and specify a subset of IPs within that range. So what we're going to do is we're going to go and create a new subnet. This is going to be a class B, and we're going to be using a subset of those IPs. So for example, let's say we have 4 Docker servers and all of them will be using ranges from this class B. So the network we're going to be setting up is going to be using a class C from that class B. And if we take a look over here, and how we go about specifying that is that we use the IP-range flag and then specify the subset of the network we're going to be using. So we'll be running docker network create. We're going to be using the subnet flag and specifying our class B, which is 10.1.0.0/16. We also need to specify the gateway, which is going to be 10.1.0.1. And again, this is the IP that will be assigned to our bridge, and our bridge will be assigned to all the interfaces on our server. We then use the flag IP-range and specify the subset of IPs we want to use. We're going to be using 10.1.4.0/24. And just because we haven't used it yet, I'm going to use the driver flag and specify that the driver is going to be bridge. We also haven't used the label flag, which we'll be using now, and we want to make sure that our label is being set to host for network, and we'll be calling this network BR04. All right, now let's go and list our networks. Okay, so far everything looks good. BR04 was created. Now let's go and inspect it. Let's start off by coming over here and looking at config. We can see that we have our subnet being populated here. This is what we defined when we created this network. And what is different than what we've done previously is that we now have an IP range showing up, and this is our class C. Also, our label is showing up, host for network, and that's pretty much it. Everything looks good. Now that we've gone and created this new network, let's go and create a container that will use it. In the previous lesson, we learned about the connect command, but this time I want to go and create a container that's going to automatically be assigned to that network. So we're going to be executing docker container run. We're going to specify the name of our container, which is going to be network test 01. Because we'll be interacting with the container, rather than use the D flag, I'll be using int. When we want to go and specify what network we're attaching to, Now to go and attach a container to a network, we use the network flag and then specify the name of the network we want attached to. Now, the great thing about this flag is we can use it multiple times if we want to attach our container to multiple networks. We'll be using CentOS as the image and bin bash as the command. All right, now that our image has downloaded and our container created, we are dropped into the prompt of our CentOS container. The first command I'm going to run is yum update-y, and this will take a bit for everything to update. Now that the update is finished, I want to go and install network tools. So execute yum install-y net-tools. Now that NetTools have been installed, I can run ifconfig. And when we go and take a look at ETH0, we can see we have the first IP from our range, which is 10.1.4.0. And this is the first IP in the IP range in BR04. Also, I can run a netstat-rn to get the gateway information that is assigned to our container. And this is the gateway that was defined for BR04. So in cat etcresolve.conf, we are using the local name server from within Docker. And all this is being managed through the bridge network. There's 3 files that are mounted into the container that Docker manages for you. It's etc hostname, etc host, and etcresolve.conf. So under the hood, Docker manages all of this for you and you don't have to worry about it. Let's go and ping google.com. And you can see we are getting a response back, which means that DNS is indeed working properly. I went ahead and exited out of the container, and you can do this by typing exit. And we're now ready to move on to the next scenario. So what happens if we want to go and make sure that a container gets a specific IP? Well, we can do this by using the IP flag. Now we're going to go and execute docker container run. We're going to be using the D flag, so our container runs in the background. We're going to name the container network-test02. And now we're going to be using the IP flag, and we're going to specify 10.1.4.102 as the IP. We'll be attaching this container to network BR04, and we'll be supplying the Nginx image. Rather than use the CentOS image like we did previously, we're going to go and use grep to get the IP information. Now we're going to go and execute docker container inspect network-test02, and we want to make sure that we pipe it to grep, and we're going to be searching for IP adder. And the IP does match up with what we defined within our Docker container run. Now we're going to go and take what we've learned and apply it to networking to different containers. The first thing I'm going to do is I'm going to create a new bridge network that is going to be internal, and it's going to be called localhost. By using the internal flag, we're telling Docker that we don't want this network to be bound to any of our interfaces. Now we're going to go and create a MySQL container. We want to make sure that's running in the background, so we're going to be using the D flag. We're going to name the container test_MySQL. Now, we haven't talked about the E flag, which is the environment variable flag. We'll be talking about it in a little bit more detail later on. But for now, we're using it to go and define the MySQL root password. We're using the network flag to add this container to the localhost network, which means we won't be using the default bridge network. If we wanted to use that network, we would have to go and use the network flag again and then specify the bridge network. To finish off this command, we're using the MySQL image with the tag of 5.7. Our second container is going to be a CentOS image. We're going to name it ping MySQL because we're going to be pinging MySQL. And we want to make sure that it exists on both the bridge network as well as the localhost network. I'm not going to be using the D flag. I'm going to be using int because I do want this to be interactive. Now that the container has been created, I should be able to go and ping MySQL. And to achieve this, we simply use the name of the container. And as you can see, we are able to go and reach MySQL. Now I'm back at the prompt, and we're going to go and create another container. This time, it's not going to be on the localhost network. So when I go to ping MySQL, we shouldn't get anything back. And as you can see, we're not able to go and ping it. I'm back at the prompt again, and to exit the container, just simply type exit. Now we're going to go and create an Nginx container that is going to be running on our localhost network. We do want to make sure it's attached, so I'm using the D flag. I'm naming this container private-nginx, and I'm publishing 8081 on the host to 80 on the container. And again, I'm making sure I'm using the localhost network, and we're using the Nginx image. When I go and curl localhost :8081, we're not getting anything back. And the reason why is because this network is internal. It's not bound to any of the interfaces on the Docker host. But I can do a Docker inspect on the container By using the private IP assigned to the container, I can curl it and get a result back. Okay, so we are now done with the networking section. Go ahead and mark this lesson complete and move on to the lab. Coming up next, we're going to start talking about volumes.